Hi, this video we're going to look at another example of finding 2D resultant using the universal method, decompose to x and y component. And this problem is different from the previous one. How so? Is only difference is just have like 4 forces. The previous one have 2 forces. However, we're using the same strategy. First step, remember, is we're going to decompose this force. Decompose each one of the 4, and since we have more to manage now, we have 4 forces, and it's really to our benefit to create a table. So I'm going to try to create our first row, second row will have force 1, F2, and F3, and F4. So when we have that, and be aware what we're trying to do is we're going to decompose them to x component, x direction, or x component, and also y component. Okay, so hopefully this table will facilitate, organize our numbers here. So let's take a look at it. F1 is right here, and if I'm taking F1 out, this is my F1 is 150 Newton, and F1 giving us the degree here is 30. We're going to decompose this to rectangular x component and a y component, and now actually that's going to be F1x. Since it's the x direction, this is up, so it's at a y direction, F1y. And I no longer draw those dashed rectangle line anymore because I just kind of eyeball it to know where to stop, right? So F1x, what's the value? We need to put it in here. That's our F1x. So this is where we're going to put it, and this is going to be our y component. So how do we find that? Rule of thumb again, if this angle 30, when you solve this, F1x, it's adjacent. If it's adjacent, you are using cosine. So it's 150. This force you are decomposing times cosine 30 degree. The F1y is going to be 150. Since this angle is 30, it's opposite to 30, so we're using sine 30 degree. And sine 30 is 0.5, so I can quickly calculate that's 75 degree. And here, I'm going to use my calculator, 150 times cosine 30 degree, and that gives us a value as about 130 or 129.9 to be more precise. All right, so we are going to do the rest of the 3 forces the same thing. Now let's look at F2. F2 is this one here, and we're again isolate that force out. This is our F2, and it's 80 Newton. And the angle here is 20 Newton with respect to y-axis. All right, now we're going to decompose to x component. X is left and right, and we're also going to decompose to y component. So that's going to be our F2x and F2y. Immediately, I want to bring you to attention is F2x is pointing to the left. Since it's going to the left, our sign convention is our x coordinate and y coordinate is this way. So when x is when the direction is pointing to the left, we know this force is going to be what? Negative value. And that's when I emphasized previously, have to watch out for the sign here. Okay, so now let's go ahead and find the value for that. F2x, and if this angle is 20, and this angle would be 20 degree as well, and F2x with respect to 20 degree is opposite. Rule of thumb, if it's opposite, you're going to use sine. So we're going to use 80 times sine 20. And however, remember we said this force is going to the left, so be really careful. There is negative sign in front of it. Okay, I cannot emphasize enough, the sign is very important. So F2x is going to be negative 80 sine 20 degree. And now let's look at F2y. F2y here is going to be this hypotenuse 80 Newton times this angle is adjacent, so it's cosine 20. So it's 80 times cosine 20. So let's go ahead and put into your calculator 80 times sine 20, and so that gives us a value of negative 27.36. And for y would be 80 times cosine 20 degree. That gives us the value of 75.18 Newton. All right, so we did 2 and have to go. We're going to use the same method on the remaining one. F3. F3 is a unique situation, right? Because it is pointing straight downward at y direction, negative y direction to be more precise. So when you have this perfect force that's on the x or y axis, what's the decomposed component? So what do you think? F3, what is x component? What's this one here? What's our F3x equal to? Well, if you think it's 0, you are correct. Because the entire force is lined up at y direction. And this y direction, if you think it's negative 110, you are correct. Why? Because it's going downward, this force. So this one, be sure, is going to be negative 110 here when you put it into the table. Okay? Here, a sidetrack. If I have a force, hypothetically, if I have a force going this direction as 20 Newton, what do you think this force x direction going to be? That's going to be positive 20 because it's going to the right, because it's completely lying on x direction, and Fy will be equal to 0. Okay? All right, that's sidetrack, so I'm going to just break it up. Now let's move on to the last force, F4. Isolate that force, F4, and this is 100 Newton. And this angle here is 15 degrees. We just copy that down. When we decompose this force, this is going to be our x component. This is going to be downward because it's going downward. That creates your rectangular component. This is going to be your F4x. This is going to be your F4y component. Then we're solving it. F4x is going to be 100 times sine or cosine. If you think it's cosine, you are correct. Why? Because it is adjacent to that angle. F4y is going to be equal to 100. And now this angle is 15, right? And the y direction is opposite to this angle. So opposite, you are using sine. And however, pause for a second. Think about the sign. This is going downward, so F4y have to be what? Negative value, negative 100. So go ahead, put this value in there. F4x is 100 times cosine 15. And F4y is going to be negative since it's going downward, 100 times sine 15 degree. Then let's go ahead and put it into your calculator. Now, first value is going to be 96.59. And the second one will be 100 times sine 15. And that's going to be negative 25.88. So we have finished our first step. Hopefully this table will help us organize those numbers together and review this part. And the pitfall is watch out for the signs. And another unique thing we learned, when the force is going to be perfect vertical or perfect horizontal, then you know the other component will be 0, right? Okay. So knowing that, we're going to move on to our step number 2. Is we're going to add all of those together, sum all the x, and also find out sum all the y together. In order to do that, I would like to just add another row in my table, and I'm going to say this is going to be my summation row. So to do that, this is all the x component, right? All this left column, and I'm just going to add them all together. So add all those values here together. So let's go ahead and try. we have 129.9, add the negative 27, so basically minus 27.36, and then plus 0, then plus 96.59. And then I will get the answer as 199.13 Newton. Okay, so we have summation of forces at x direction. Then we're going to do the same thing for summation of forces at y direction. All of those here together. So when we add all those together here, let's see, 75 plus 75.18, then minus 110, basically plus negative 110, then minus 25.88. Then we have an answer as 14.3 Newton. So that's going to be all the y components add together considering their signs, right? Going upward, downward, all together. And then we're going to get our last step because our goal is finding the resultant of all those four forces here together. And we're going to use our equation. The resultant magnitude will be using Pythagorean theorem of fx. Sorry for my messiness here. So square root of summation of fx squared plus summation of fy squared. Then put them together. You have 199.13 squared plus 14.3 squared. Add them together. So let's put in the calculator. So we have that plus 199.13 square, and then take a square root of that. We have answer as 199.64. I mean, this number makes sense, right? Because this one is like dominant compared to 14.3. And so that's going to be your magnitude of this resultant force. Then direction, because it's a vector, we're going to define the direction. Direction is theta. That theta is defined from x-axis counterclockwise to this force, and we know it's going to be inverse tangent. That's the equation. Sum of Fy over Fx. Then Fy is 14.3 over 199.13, and then take inverse tangent of that. Then we have an angle super tiny, 4.11 degree. Again, makes sense, right? Because if I were to exaggerate, my sum of x would be very long. My sum of Fy will be very small. And in order to, when you find the resultant of that, you know, you basically draw a rectangle. That's going to be your resultant right there. You know, like, so this angle is very small, 4.11 degree. Okay, that gives us the direction of this resultant. And this is the magnitude. All right, so this is how we generally solve 2D resultant when you have multiple forces, like 3 or more, using the same strategy. Put the table to facilitate, and make sure consider signs, positive and negative. Pause for a moment before you move to the next, and then that's it. All right, I'll see you next one. Bye.